what are we looking at? Parotid gland. How do you know? Start from the most general separating. It's got ducts. All right. In this field of view, I mean, I'm telling you this is, you're right, this is parotid. But all you see are serous acids. If you look throughout the whole slide, that's all you see. So, we've got some tissues like liver and gallbladder, and then we've got the dreaded purple, the parotid, submandibular, pancreas, and parathyroid. All right? For those slides, I'm going to be yakking at you distinguishing features, and we started here. So one distinguishing feature is presence or absence of ducts, because that marks it as exocrine. All right? So as Garrett said, clearly we got ducts, and all we can see are serous acid. Again, adipose tissue dependent on the nutritional status of the individual from which it was taken. All right? Higher power, we can see nicely the serous acid. Here this looks like it might be an intercalated duct here. Looks cuboidal. Name's on second verse. If we look at the, this is cool. This is a major excretory duct. All right? What kind of epithelium is lining the duct? Stratified columnar. Okay, and you have to go to, like right up in here. Clearly columnar cuboidal. And then, what's this right here? Come on, let's not forget. Nerve, exactly. Remember that there's an autonomic innervation here to the gland. All right. Here is a high power shot of a salivary gland. It's got a duct. It's got serous acid. It's got mucus and seromucus. So it has to be submandibular. Now, again, a warning, and some of you have noticed this. You know, when you look at submandibular, you're going to want to do the bi-eye, low power around the sides, and as you're doing that, you're picking up information. What you're going to realize is that there are a lot of serous acid in a submandibular gland. And it's these mucus and seromucus acini which help you tell what it is, but they're not all over the place. So you need to look carefully, all right? And then I think I threw in here, this would be what the sublingual gland looks like. Mostly mucus, a few serous acid. So again, just to go over the basic structure of the liver, we've got these hexagonal shaped portals with the central vein or the terminal hepatic annulus in the center, and the portal tracts around. In the hepatic lobule, blood flows this way, lymph and bile flow this way. I mean, it makes sense because the bile duct's out here, right? So bile and lymph are moving that way. If we think about it in more functional terms, in terms of perfusion, the acinus is a nice way to look at it. And that is, you take one side between two tracts and realize that you're getting your blood supply here, and it's draining to the central vein. Then you have these zones where very well perfused, or a better way of looking at it, first come, first serve. Zone 1 gets first crack at all the nutrients. Zone 2 gets what's left over, and Zone 3 gets what's left over as both Zone 1 and 2 have feasted. All right? And you can then realize if you've got a situation like congestive heart failure, it's the last to feast that are the first to die. All right? If we look then at liver, I mean, liver has kind of a distinctive structure. You know, the hepatocytes, lots of sinusoids, and then structures, what are we going to call this? Triad tract or canal, right. And even at this power, you can see the bile duct. Here you've cut the lumen, here you're glancing it. Probably hepatic artery or branch thereof. Big vein, and these irregular spaces, probably lymphatics. Out here, nice central vein. Another branch of central vein right here. But you can see nicely these hepatocytes with the paler staining sinusoids on either side. Higher power of that same tract, and you can look to see clearly that was a bile duct. Here, the hepatic arteries oftentimes are squinched down, so the endothelial cell nuclei kind of bulge into the lumen. And here's your big branch of the portal vein. Right here looks like a lymphatic. There's an endothelial cell line here. This, the animal from which this slide came was injected with India ink, so they're carbon particles that are phagocytized by the Kupffer cells. So we see nicely then Kupffer cell, Kupffer cell, Kupffer cell. And note that all the Kupffer cells are in the sinusoids, either straddling the aperture or sometimes actually make up a bit of the wall where there's a discontinuity, endothelial cell discontinuity. What's this right here? Yeah, it's another branch of the bile duct. Here we've got bile duct and bile duct. Again, it's that cuboidal epithelium lining it that tells you it's a bile duct, provided you know you're in the liver. Here, obviously, this is one of my favorite micrographs. See our old friend, the Kupffer cell, the way it's kind of spanned. It's just in perfect position to phagocytize anything that's coming in. Unfortunately, it's probably got cracked off there. This is a cool shot right here. So let's get oriented. This is a hepatocyte. You can see microvilli, lots of mitochondria. Here's the sinusoidal lumen. This is a Kupffer cell, and this is a discontinuity right here in the endothelial cell. So here the Kupffer cell is kind of forming part of the sinusoidal wall. And this cell right here is the lipocyte of Ito, or the stellate Ito cell. Lots of lipid for that vitamin A synthesis, the retinol. And this cell, oh, here we go, right there, produces the reticular fibers. There's a little bit of a collagen. So this cell is hanging out in that space between the hepatocyte and the sinusoidal wall, the parasinusoidal space of Dis. This is a nice shot here. So what do we think we're looking at? Well, we've got these folds, villi, kind of like folds. We've got, well, first a bunch of crap in the lumen. So that's bile that didn't get washed out. And we got these beautiful folds set on a connective tissue, and then we start getting big muscle bundles right here. So the first thing I'd start looking for is, do we see goblet cells in this lining? The answer to that is no. You want to start thinking gallbladder. You can help yourself out by realizing that you've got a lamina propria under the epithelium that comes down, and immediately you're into the muscle, the muscularis. So you don't have a muscularis mucosae like you do in the GI tract body wall structure. And you don't have a submucosa. All right? That, in addition to the fact that you've got no goblet cells, tells you you're looking at gallbladder. Are there ducts? Got ducts. Are there serous acini? Lots of them. So just based on that, this could be the parotid, right? Except for these puppies. Islands floating in a purple sea. Islets of Langerhans. That makes it pancreas. So again, you see how just ducts and a few superficial characteristics on top of that help you start to sort these guys out. Same song, second verse. You know, you've got ducts. Here you can see these probably intralobular connective ducts in the connective tissue here. Lots of acini, and then you start picking up your islets. So another pancreas. Here's a higher power shot. Here's your islet. Remember, these structures are roughly spheroidal or spherical. So the diameter of the circular profile is going to depend on where you cut it from the pole to the equator of that mass. If you look out here in this serous acini, in this region right here, in here you get that reddish or crimson color. If you were to look at this with high power, those would be the zymogen granules that contain what? Exocrine portion of the pancreas. All the pancreatic enzymes, the digestive enzymes. Okay, so that's red. It's basophilic because of a lot of rough ER, and you've got these red granules up in the apical region of the cells in the acinar. All right, moving on to endocrine. Again, a lot of the slides of the pituitary were not sagittal or parasagittal sections like this. They were actually more frontal sections, so you're looking down on it. What we're interested in is that you know, are able to distinguish, identify it as pituitary, distinguish that it's anterior or posterior, and be aware of the fact that the anterior pituitary has acidophils and basophils. Be aware of the fact that a lactotroph and a somatotroph produce PRL, prolactin, and growth hormone, and they're acidophils, all right? So basic, I don't care that you can identify an acidophil versus a basophil, but intellectually I want you to know the difference. And I want you to know what hormones they produce and basic what they do. So at any rate, this is parasagittal. We've got probably pars distalis here, pars intermedia. Notice the cyst that's filled with colloid. That's a remnant of that embryonic outpocketing from the oral cavity. You don't see much of the pars tuberalis, but it would be in this region, wrapped around kind of like this of the stalk, the infundibulum. And then clearly you can pick up the pars nervosa here. Here's a higher power shot. So, oh, I'm starting to die. Intermedia, right in here, distalis, nervosa. You know, relative, more basophilic, more acidophilic. So maybe acidophils, basophils. Again, keep in mind, notice lots of capillaries. All the red blood cells here. And again, the whole herring body thing is something that we don't see very well in our preps, but that doesn't mean that you should not look at an electron micrograph like the ones I showed you and be in tune with the fact that oxytocin and vasopressin, or ADH, are what are traveling down those axons of the 100,000 or so unmyelinated fibers to be released. And again, have a feel for what their function, basic function is. Thyroid, old friend the thyroid. Oftentimes when you see this kind of situation, the thyroglobulin is being resorbed. Note that, I think I have that. No, I don't. Again, keep in mind that the height of the epithelium, I mean, this is pretty low, so I expect this to be relatively quiescent. But it can be columnar when it's resorbing or producing the thyroglobulin. A nice shot because it shows the parathyroid in its entirety in association with some thyroid gland. Keep in mind that we will show you good specimens or micrographs, right, Nigel, for the exam, all right? So again, med picks, if you're not happy with the quality of the slide, that doesn't mean don't look at the slide, but go to your ancillary sources. So, purple staining, and the major question we're going to be asking ourselves, first to start off with, ducts or not, right? And since we know the parathyroid is an endocrine organ, it's not going to have ducts, then it's going to cause us to pursue further, and we're going to want to look for clusters of oxyphil cells, or oxyphil cells singly. Not really sure what oxyphil cells do, but as Harry pointed out, their eosinophilia suggests that they're full of mitochondria. At any rate, the fact that they're pink staining and appear in clusters is a nice secondary characteristic in addition to no ducts to tell you you're looking at parathyroid. Adrenal gland. And this is something we've got to address. The staining is really poor quality on this. But nevertheless, if you have a sharp eye and are willing to do it, look, you can distinguish an outer cortex surrounding an inner medulla, and key features on the medulla are these large medullary veins. If you look at well, you can almost hallucinate that reticularis tends to be a little darker staining. So that's the region of the fasciculata. And then the glomerulosa, oh, here's it. Glomerulosa should be right subjacent to the capsule. The higher power shot, we can see these clusters, rounded clusters. So from here up is probably glomerulosa. And then notice how there are these bands. So this would be fasciculata. And here these bands are all interconnected. So reticularis to about here. And you get into here and you're talking medulla. Higher power showing the capsule up here, and between the arrows in circular glomeruli or clusters of cells. Here you can see nicely the vasculature which drains down into the medulla. So that's it. Remember, with respect to the dreaded 4, ducts or not, serous acini only, mucoserous acini, islets, and oxyphil cells. I mean, you know, those 4 or 5 characteristics should help you distinguish